This video was brought to you by the ILC. Hello there once again. Welcome back to our Exam Review 1 series. This time we'll be doing problem 13, and we'll begin with problems A and B, where we are asked to find the domain and range of function f. Function f is the function on the yellow line, and function g is the function in the blue line. For now, let's only look at function f, and let's try to find the domain and the range. For the domain, we look only at the x values. And when you're trying to do a domain, it's a good idea to get a number line. So let's begin our number line by drawing the left and right arrows. The function begins at this position. This closed dot has a position of -8, 6. Because we are only looking at the x values, let's look at -8 and place a closed circle in that position. Let's follow that piece to the end, which is this position. We have -2, 1. We'll place another closed circle at -2. However, also at -2, down below we have an open circle. But remember, when you have to make a choice, choose a closed circle. Now, from that position at -2, -2, let's continue following this line toward the right. We reach this position, 2, 6. Let's again use the x value. It is a 2, closed circle. Now the function skips downward to 4, -6. Also a closed circle. We follow that piece to the right, and we reach the final point, 8, -4, put a closed circle at 8. However, let's make a note that the function does not exist in between the 2 and the 4, so we'll X that out. Now, ordinarily, this -2 would have caused a break in the function. However, since it's closed, that doesn't count as a break. So our first region, which we'll call region A, will be this region between -8 and 2. The second region, which I'll call region B, will be between 4 and 8. So my domain will be this. -8 to 2. Both of them are closed circles, so we will use square brackets. Union, piece B, which is 4 to 8. Those are both closed as well, also square brackets. Now for the range. For the range, we use y values. We'll follow this function from the bottom up to the top. Our lowest position is for -6. But -6 is the y value. We'll begin there. Because it's closed, we use a square bracket. Follow that piece upward, again to 8, -4, but we're going to use -4, since that's the y value. Closed bracket on that. Now, union, and go upward to the next piece. The next highest point is at -2, -2, and the y value is, of course, -2. Because this is open, we will use a parentheses. Follow that piece upward. The highest that piece goes is +6. So we'll place a +6, and because it's closed, place a square bracket. We do have a third piece over on the left side, but notice that piece also stops at +6. So there's no need to write it twice. Our second part of the range can be -2 to 6. Now we can start on problem 1C. Problem 1C says find 2 times f-1 plus 3. The f-1 means that when x is -1, find the y. -1 would be located about here on the graph. It's a little difficult to read the y value here, so we may not be perfectly exact, but it's definitely between 0 and 2. So we'll say this is roughly 1.5. So to find the answer, we say 2 times 1.5 plus 3. 2 times 1.5 gives us 3, plus the additional 3 would give us 6. That would be our answer for 1C. We'll do this problem slightly out of order and skip ahead to 1E. Here in 1E it says to find 2 times f at -8 plus g at 2. So we will need to involve the blue line in this problem. First, f at -8 means to go to function f, get where x is -8, and give the y value. Now this is going to be the yellow line. Let's go to -8. That's going to be here. Here's where the -8 is, and we're going to return the 6 as our answer. We will replace the f -8 with a 6. So our expression now says 2 times 6 plus g2. Now we go to the blue line. On the blue line, where x is equal to 2, that's this position, the y is -4. So we'll say plus a -4. Now we do the math. 2 times 6 is 12. Subtract 4 gives 8 as our answer. Now on to problems 1D and 1F. Problem 1D says, if gx equals -4, what is x? So once again, we're going to use the blue line. And when it says gx equals -4, we're going to let y equal -4. And we're going to see where we cross the blue line. So let's draw a horizontal line through y equals -4. I can see 2 positions where the y is equal to -4 on the blue line. Here on the left and here on the right. So we would return our x values as our answers. We have -2 and 2. Both of them match the criteria that y is -4. All we have to say is x equals -2 and x equals 2. Now for problem 1f. We are asked, is the inverse of function g also a function? To answer this question, we will need to do both a vertical line test to see if it's a function and a horizontal line test to see if the function is 1-to-1. Let's look at function g now. If we try to draw a vertical line through function g, we can see that it's just not possible to have it cross more than one time. So we would say that function g does, yes, pass the vertical line test. Now we've already drawn a horizontal line through function g, and we can see that it crossed in 2 positions. In that case, function g would fail the horizontal line test, and we would say no. Therefore, because function g fails the horizontal line test, the overall answer would be no. The inverse of function g would not be a function. Thank you for watching. We'll see you again soon.